So let's go ahead and continue on the back side. The first step to do is get the absolute value bars alone. Now that doesn't make too much sense right now, or maybe it's all coming back to you. After that, second thing, then you're going to split it into the negative and positive versions of itself, then solve it. So let's begin with example number 1. What we need to do is remove our constant, -5, by using the inverse operation to eliminate it from the left side and move it over to the right side, leaving us with the absolute value of x is equal to 16. So we've done step 1. Let's move on to step 2 and split it into the negative and positive versions. Now, what I'd like to do is something a little bit easier than what we did on the front side. Rather than putting the negative on the left side of the equation, let's just put it on the right side. So here I've listed out my positive version. Let's do our negative. Boop. So last thing to do is to check our solutions. Yes, we have to check it. So let's go ahead and put it back in for x. So the absolute value of positive 16 is just 16. 16 minus 5 is 11. Checks. Negative 16. Recall what we had said on the front, and that's the distance from 0. So again, we end up with the exact same thing. Check. And let's go ahead and write in our solution. Now on to example 2. Again, we're going to get our absolute value bars alone first. Similarly to last time, I do have something outside my absolute value bars alone. So remember, I'm thinking of this as my actual kind of like variable. So let's remove our constant of positive 4 by subtracting it from both sides, eliminating it on the left, and leaving us with the absolute value of 3x minus 1 is equal to 2. So step 2, split into our positive and negative version. So let's start with the positive. Now remember, I'm going to put my positive on the right side, and let's go ahead and solve by removing our constant, -1 with positive 1, 2, eliminate on the left, leaving us with 3x is equal to 3. So of course, 3 and x are being multiplied. Inverse operation is division of the coefficient, 3. Now that will cause this 3 over 3 to reduce to just 1. X is equal to, again, 1. Sorry, I kind of really squeezed it on there. Let's go ahead and repeat this process, but with the negative version on the left side. And I'm going to go ahead and put my negative with that 2, and we're going to do the exact same steps. But what you'll notice is that this time, I again have 3x equals, interesting, -1. Which is not the same as what I ended up with last time because this is the negative version of it. So last step again, we divide both sides by 3, leaving us with x is equal to -1/3. Let's do our check and substitute in for x. Now, 3 times 1 is just, 3. 3 minus 1 is 2 plus 4. So we have the absolute value of 2, which is 2, plus 4 is 6. So first one checks. Now let's check the second one. 3 times -1/3 minus 1 in the absolute value bars. A third of 3, or 3 over 3, that's going to reduce to 1. So now we have -1 minus 1, which is simply -2. And the absolute value of -2 is 2. 2 plus 4 is also 6. So it checks again. Let's write out our 2 final solutions, of course in ascending order. Example 3. Now example 3 is, a little different because my absolute value bars are already alone. So I immediately split into my negative and positive versions. Now, what I'm going to do first is rewrite everything without my absolute value bars like I usually do. Now, you'll notice that we're in a similar situation like the example that we had at the beginning. I put my negative in the front, then I have to distribute, and that's just a big old mess. So instead, what I'd like to do, rather than applying my positive and negative to the right side where there are multiple terms, I can simply apply them to the left side where I have one term. And this is just to make my life easy. And that's what it's about. So let's start solving. It doesn't matter which side we begin at, but the step is always going to be the same. Reverse that. Before, our first step was to remove our constant, but since we already have our absolute value bars alone, we have this weird situation that we have x's on both sides. So let's combine our x's. Since I have a positive 1x, to remove it, let's eliminate it using subtraction on both sides, of course. That leaves me with negative 8x is equal to negative 6, and the same step as before to get my x alone, I would divide by the coefficient of negative 8 on both sides. Negative 8 over negative 8 reduces to 1, leaving me with x is equal to 6 over 8, which of course could be reduced to x is equal to 3/4. Let's go ahead and do the other side, the positive version. Starting with the same step of moving the x, 1x, to the left side via elimination, leaving us with 6x is equal to negative 6. This time we have a different coefficient, but we get rid of it just the same way using division on both sides of the coefficient, positive 6. That reduces to 1, x equals negative 1. Yes, I know you guys hate it, but let's check our answer. It's really important on this one because I have x's on both sides. I need to substitute this negative 1 into both sides. So let's begin. 7 times negative 1 is actually going to give me the absolute value of negative 7 equals negative 7. We already discussed this. We know that the absolute value is distance. Distance cannot be negative, so in that case, negative 1 does not check. So let's check the other one, 3/4. 7 times 3/4 is equal to 3/4 minus 6. Doesn't sound right. But let's go ahead and get that done by multiplying straight across. That's the absolute value of 21 divided by 4 equals, let's change that 6 into a fraction like 24 divided by 4, because then we can get negative 21 over 4. So we're in that same position again that 3/4 does not check. So what do I write for my solution? Yeah, no solution. Let's move on to something easier. Again, step 1, get the absolute value bars alone by adding 2 to both sides, leaving me with, we have something a little different here. The absolute value of 2x is greater than or equal to 10. Because yes, we can do these exact same steps, but with an inequality symbol. So let's see what that looks like. Well, now that the absolute value bars are alone, let's split into the positive and negative versions. This looks a little funny. So I have my positive 10 and my negative 10. Nonetheless, I still have 2x, and what I would do for the positive version is simply divide both sides by the coefficient 2, leaving me with x is greater than or equal to 5. Now, I'm going to cover up the positive side and do the exact same thing over to the negative side by dividing by 2. So now it'll look like negative 5 is greater than or equal to x. Altogether, we have negative 5 is greater than or equal to x greater than or equal to positive 5. My challenge to you, 5 and 6, with a slight twist. Change number 5 to be an inequality